class is going to try to explain the basics of recursion. Alright, so let's try to write a little recursive function. Define f of x. If x less than or equal to 1, let's simply print x. So the function will simply print the number. Else, well, let's print x, and let's run f of x minus 1. All right, let's save the file, and let's run this in the shell. All right, so I copied it to the shell. So now we could utilize the function. Okay, so let's try to run it. So if we do f of 1, well, that's easy because it just used the first part of the if statement. So let's try f of 2. All right, see what happened there? It printed out 2 and 1. So how did that happen? Well, when x was 2, it went here. So print the number 2. Okay, it did that. It printed the number 2. Then run the same function f, but this time with 2 minus 1. 2 minus 1 is 1. So it runs this code again, but this time for x it plugs in 1. And that will just result in printing out 1 right here. So let's try f of 3. Well, f of 4. You see the pattern? F of 1,000. Doesn't like that. There's only so many levels of recursion you could do. So let's go to f of 10, and we see that. All right, let's modify our recursion program a little bit. So let's say instead of x minus 1, we'll go down to x minus 2. All right, so let me copy and paste this into the Python shell. All right, f of 1, f of 2, f of 3, f of 4, f of 9, f of 10. All right, so we see what it's doing. So if we do, let's pause it. One way we could see this better is if we pause things. So we could say something like this. Print hello running f of x So now we know each time it runs something, we know what it's doing. And in fact, well, let's just try this out. All right, so now we can see which copies of f are actually running. All right, so f of 10. All right, so hello, running f of 10. Okay, so x is 10. So what does it do? It prints 10, and then it runs f of 8 next. Okay, hello, running f of 8. So 8 goes to this part, it prints 8, and runs 6. Eventually, it'll get to 2. All right, running f of 2. 2 is greater than 1, so it goes here, it prints the 2, and then it runs f of 2 minus 2, which is 0. Finally, it runs f of 0, and 0 is less than or equal to 1. We're done. So let's try it with f of 9. And as you can see, the last one it runs there is f of 1. Okay. All right, let's try a little bit of a more complicated recursive program. All right, so if x is less than or equal to 1, return 0, else return x plus 2 times f of x minus 2. And just so we can see what's happening, we could do something like this. Print running with argument x let's say starting f of x with argument x, and then at the very end of the function, when it pops, when it finishes, we can say ending f of x with argument x. So now we know when it starts and when it ends. Okay. There's something a little off with my my program here. All right, so let's try it out. Oh, there's a mistake here. Let's see. Oh, I forgot this. All right, now yeah, there's some little typos there. Okay. All right, so let's try this one out. All right, so f of 1, starting f of x with argument 1. Well, okay, so we finish also when we get to this point. So let's put it right here too. Okay, because this is, things terminate when you get to this line. All right, let's try it again. All right, so f of 1. Starting f of x with argument 1, ending f of x with argument 1. Okay. All right, so f of 1, starting with 1, ending with 1. And here's the output, 0. And where does that come from? Well, that's the value of the function. So f of 1 returns 0. All right, let's try f of 2. All right, so take a look at this one, f of 4. Try to figure out what's happening there. All right, so let's see if we can trace it. So first, it gets to this line when x is 4. And this is not true, so it goes here. All right, the answer, return x, so 4 plus 2 times f of 4 minus 2, which is 2. All right, so next it's going to run f of 2. Okay. And maybe it might be helpful if we can see what it's returning, right? Well, that might be a little tricky. You can try. Let's see. Print returning str. So let's put this inside. All right. Maybe this will be a little more helpful. Let's see. All right, f of 10. A little too big. All right, f of 4. Okay, so what happened here? So we started with x equals 4, and as soon as it got, this actually made things a little more complicated for the computer. So let's see, as soon as it got to here, it needed to call f of 2. 4 minus 2 is 2, so it had to call f of 2. So it called it right there. As it called f of 2, it went back up to here, and it started with 2 here. So that's why we get this here. 2 is not less than 1, so it went back here, and then it said okay, so when it got to 2, it tried, see, it can't really do this line until this is done. It's like it can't print the word returning because it's connected with this. If I put returning up here and then did this, it wouldn't treat it as one statement. So perhaps this is making things a little too complicated. But before I erase it, let me run a few examples, and you could try to puzzle it out a little bit. All right, so f of 6, so this is the output. right? F of 6. As you can see, this might be a little much for a beginner in recursion. Try F of 4, F of 2, F of 3. All right, so let's erase this and try to reason it out from here. All right, so F of 4. All right, we start with 4, and then we go here. Okay, the answer to the function is f of is 4 plus 2 times f of 2 minus 1. So let me do the calculations out here as a separate exercise. Let's see what it's doing mathematically. So the answer is, so f, what is f of 4 equal to? It's equal to 4 plus f of 2. Well, what is f of 2 equal to? That's equal to 2 plus f of 0. What is f of 0 equal to? Well, f of 0 is 0. So now we can say f of 2 is 2 plus 0 equals 2. So we know f of 2 is 2. So f of 4 equals 4 plus f of 2. But f of 2 is 2, which is 6. Sorry, there was a little mistake here. I forgot that little 2 there. All right, so let's fix it. So it's equal to 2 times, so 2 times 0, 2 times 2, 8. All right, so what's f of 2? F of 4 is 2 plus 2 times f of 2. Well, what's f of 2? 2 times 2 times f of 0. Well, what's f of 0? 0. So f of 2 is 2 plus 2 times 0, 2. What's f of 4? Go back to here. 4 plus 2 times f of 2. 2 times 2 is 4, so we get 8. So we see here it's run. Here's the output, so I could get everything on one screen view. Okay. So started f of x with 4, then it started f of x with 2, which itself started f of x with 0, and then it filled everything in. When it got to 0, it ended when it got to f of x with 0. And one thing okay. So we never see this. See? The reason we never see this is because we're returning. If you return, you exit the program. All right, so let's see if we can make one more example, but this time without using the return, just using printing. So let's try it with lists. So if length of x is less than 1, print print nothing. Okay, else print x of 0, the first character, plus, so print the first character, and then run f of x one 0 to from, let's see, so from 0 to so from 1 to the end, minus 1. All right, so let's give this one a try. All right, so now f of, let's do it with some strings. Hello. All right, so let's see what it did. So when we had the full word hello, it simply, the length of hello is 5, so it went here. So printed the H. Then it ran the function with f of this substring. So let's look at that substring. So x equals hello. So what is that substring x 1 to minus 1? So that substring, it took away the first and the last, right? It took away the first string and the last string. Remember, it does not include the very end. So it includes the first, which is the E, but it's less than the end. If you wanted to include the last one, you would do this, x 1 like that. Or you could go x from 1 to 0 and didn't like that. So you could say length of x plus 1. And that's how you would get it. Okay, all right, so it looks like we're removing the first and the last. So now, this makes sense, right? So let's run it again. So first it prints the first letter, then it removes the first and the last. So then it'll print the first letter of this, ELL, which is the E, but then it will remove the first and the last, and it'll just be an L. So each time we run this, why don't we print X, just to see what we're running. All right, so let's see what we're running here. So f of hello. So it sort of messed up our output a little bit. So maybe we should differentiate this a little bit, so we know that this line is running instead of the other line. And let me just turn this into a program now. Well, never mind. Let's see. All right, so f of hello. All right, so we run it with hello, it prints the H, then it runs it with L, prints the E, then it runs it with just the L, because it removed the first and the last, and finally it gets to the empty string, and it just prints X is empty here, and it does nothing. All right, so I hope this makes